The news itself, which we'll hear more about, is that a team led by Purdue professors Michael Rossman and Richard Kuhn have determined the structure of the Zika virus, which is a critical advance in the development of vaccines, treatments, and diagnostics.
On behalf of the entire Purdue family, how incredibly proud we are, not for the first time, but how very proud we are today of a team of our eminent scientists led by the two gentlemen you're about to hear from, who have helped the world take a very, very important step forward with regard to a threat we've all been reading and hearing and worrying a lot about.
How is it that we at Purdue managed to get to the structure of Zika virus before anybody else in the world? And everybody's been looking for that structure. The structure of Zika virus, which then was produced with a microscope, which is just at my back here, was then one of the really the first success we had with this new kind of detector, and we've been extremely happy with the results ever since.
Using the electron microscope, we kind of didn't require the traditional X-ray crystallography to go down to high resolution. So we have the structure of the virus, and we have the structure of the component pieces of the virus. The virus is made up of repeating units, and we have the structure of those repeating units completely from cryo-electron microscopy, which, unlike the other structures that we've done over the years, this is the first time that we've gone immediately right down to the atomic level to understand the structure. And so that structure really gives us a blueprint for understanding the basic biology of the virus. It creates a blueprint for many other people, as well as what we might be doing, to develop new diagnostics, to develop new therapeutics against the virus, and probably also to design vaccines against the virus.
We made a recent announcement about a major investment in the life sciences, a $250 million investment in life sciences, which is targeted at leading faculty hires at a large number of faculty positions across 6 colleges and 20 or so departments. It also provides funding for advanced new equipment and resources and facilities that can facilitate work of the kind you're seeing.
We've solved the structure of Zika virus at near atomic resolution using cryo-electron microscopy. We've done it in a fairly rapid time. It was really a compressed operation in terms of getting virus and growing it in large amounts, purifying the virus, having virus that is good enough to use in the microscope, and then doing the microscopy and determining the structure from there. Once you have that, then you analyze the data, and that was also done in a relatively short fashion, in part because Zika is similar to a lot of the other viruses that we have been working on over the last 10 years or more.
This new instrumentation, only available over the last 2 or 3 years, has made it possible to use an electron microscope to obtain a picture of 3-dimensional objects to a resolution where we can almost separate the individual atoms.
Just having the picture of the virus is something that I think a lot of people will be fascinated at. You know, here's the virus that causes all of these problems, and it's something that is so small that you're never going to see it other than through this process of perhaps magic in which we have determined the near atomic structure of the virus particle. Vaccine is a preventative measure, but people are going to be infected with the virus, and so you want to develop countermeasures to once you get infected with the virus, antivirals. And the structure, once again, provides some ideas, not all of them, but some ideas of sites on the virus that you might try to interfere with that'll prevent binding to the cell or entry into the cell, or maybe the assembly of the virus particle itself.
Well, so now we have the structure of Zika virus to a very reasonable, good resolution. But that doesn't mean immediately that cures or vaccines are available. This is only the basis on which cures and vaccines can be developed. But we do have that basis now.
I will offer
Drs. Kuhn and Rossman and their wonderful coworkers who did this stupendous piece of work. My personal congratulations and my congratulations on the part of all of us here at Purdue.